Now we're going to do some examples with our point estimates proportions and confidence interval proportions. So first of all, let's suppose that we have a sample of 456 and that 212 have the characteristic that our sample proportion p hat would be 212 over 456. Which is 0.4649, 46.49%. That would be our point estimate. Now let's say we wanted to do a 95% confidence interval. Well, again, remember that we're looking at a normal distribution and we want the middle 95%. That's going to leave 2.5% in each end. So to come up with the value I'm going to need to use for z sub 0.025, I know I can look in the t-table in the 0.025 column and the infinite row. And if I do that, I'm going to go to my t-table. I'm going to go to the infinite row. I'm going to look in the 0.025 column, and I'll see a value down there at the bottom of 1.96. So I know that I'm going to use 1.96. I know that to do a confidence interval, I've got a lower bound of p hat minus z sub alpha over 2 times the square root of p hat times 1 minus p hat over n. So in this case, that's going to be 0.4649 minus 1.96 times the square root of 0.4649 times 0.5351 over 456. Where did the 0.5351 come from? Well, that's 1 minus 0.4649. So that's going to give me 0.4649 minus 1.96 times 0.0233 or 0.023 4. So that's going to be 0.46 0.4649 minus 0.0458 which gives me 0.4191. And our upper bound is p hat plus z alpha over 2 times the square root of p hat times 1 minus p hat over n, which is going to be 0.4649 plus 1.96 times the square root of 0.4649 times 0.5351 over 456, which is 0.4649 plus 0.0458, which is 0.5107. So our confidence interval, our 95% confidence interval, is 0.4191 to 0.5107. How would it change if I wanted to do a 90% confidence interval? Well, the only difference would be I would change this value based off of a 90% confidence interval, or alpha being 10% and alpha over 2 being 5%. So if we wanted to do a 90% confidence interval, that would use z alpha over 2 as 1.645. If I wanted to do a 99% confidence interval, that would have used z alpha over 2 equals, let's see, a 99% would put a 0.5% in each tail, so that would use 2.576. The calculations would still be the same. The only difference would be I would replace this 1.96 by the appropriate z value. A couple things to notice. Notice that as I increase my confidence level, the size of my interval also increases. Okay? I'm thinking about this interval as a range of what are reasonable estimates for what the true proportion might be. If I increase my confidence, it means I have to allow more possibilities, therefore my interval will be wider. If I decrease my confidence, then I can throw out some of the possibilities, and that will shrink my confidence interval. So that ends our discussion of examples for section 9.2 or 9.1 and 8.2.